Right, this question. Okay, we've got a drinks carton formed by arranging four congruent triangles, as shown. And then we've got some lengths. So I'm going to draw a bigger diagram and add some of these lengths on. So RS is 4, QP is 4, and then all the rest are 10. So these are also isosceles triangles, which is good to know. I'm not going to add 10 on every single side. And we're asked to find the volume of the carton. Now, there's no like easy formula for doing that. And when I did this question, I thought, well, can I maybe combine these into more than one shape to turn it into something that I know? But I think the answer to that is no. Um, and actually, the the way we need to about this problem is to notice that it is actually a pyramid. It's a pyramid with a triangular base, but it's a pyramid nonetheless. And the area of a pyramid is a third times area of the base times the height. Now, if you read the actual extended solutions to this challenge, they talk about splitting it into two pyramids, but I'm not going to do that. I'm going to just treat it. I'm going to first of all calculate this base, and then I'll worry about the height. So actually, I'm going to do this base triangle in blue. And then I'll draw it in just in 2D down here. It's an isosceles triangle with 10 and 10, which means I can make this 2, halve it, and I can use Pythagoras' theorem to work out the height. It's going to be 10 squared minus 2 squared square rooted, which is going to give me root 96. This actually simplifies down to 4 root 6 because 16 goes into 96, so that's a good idea. And then the area is going to be a half times the base, which is back to 4, times the height. So it's going to be 8 root 6. And I've made some progress. I've managed to find the area of the base. Now, when I did this originally, actually, I for some reason I used the cosine rule to work out I tried to work out this angle in terms of cos theta, and then I rearranged, I then figured out from that sine theta, and I used a half AB sine C, which is unnecessary because we can just split it into two and use Pythagoras. But I'm just telling you that's what I did it. Sometimes, you just go down the wrong path. Um, but yeah, that area is sorted. Now is the harder challenge. We have a height going on, and it's maybe it comes down here. There's going to be if we drop a, a perpendicular from the base going up to the height, that is what that is going to look like. And I want to find the height. If I got the height, then I'm sorted. I can work out the answer. But that's easier said than done. Now I'm going to return to this 2D picture of the shape. 2D picture of the base. Just going to look at one half of this isosceles triangle. So I know that this is 2, this is 10, and we've calculated that this is 4 root 6, and this is a right angle. Now it must be that the height lies along that line. Let me draw it in. Okay, it must go through it. And so the point that it comes down is maybe going to be here. So what I did is I thought, right, I'm gonna um, call this x, and then that's x. And this length is going to be 4 root 6 minus x. Now, how does that help? Well, actually, we can now look at this green triangle here. The height is going to be perpendicular to the base, so I have a right angle. And so I can write down, I'm going to write it over here. I can write down that h squared, the height, plus this little length, which is my x, h squared plus x squared is going to equal 4 squared, or 16. And yes, I know I've introduced another unknown, but there's something else I can do. And that is I can create another right angle triangle. Here. So for this triangle, I've got h squared plus this length squared, which is 4 root 6 minus x, and that is going to equal this length here, but that red length is exactly the same as that purple length, so it's just going to be 4 root 6 all squared, or root 96 squared, or 96. And I've managed to kind of construct simultaneous equations, which I can now solve. So I'm gonna rearrange the top one to make like a, although we want to find h, this thing in here looks quite complicated. So I'm actually going to try and find x to start with, and I can make h squared the subject. It's going to be 16 minus x squared. And then I can replace that by 16 minus x squared. So 16 minus x squared plus 4 root 6 minus x squared is equal to 96. Right, I need to expand this out. Remember, this 4 root 6 was actually root 96, so I'm just going to get 96 when I square it. I'm going to get plus x squared, and then I'm going to get 4 root 6 times minus 8, but I'm going to double that, so I'm going to get minus 8 root 6x, and that's going to equal 96. Now this works out very well because the minus x squared cancels with the positive x squared, the 96 is cancelled to leave me 0, and I'm left with 8 root 6x, if I get it onto the other side, is equal to 16. I can divide through by 8. I'm just going to take it step by step. So root 6x is going to equal 2, and x is going to equal 2 over root 6. Oh, that was good. Then remember I had h squared is equal to 16 minus x squared. So it's going to be 16 minus 4 over 6, which is 16 minus 2/3, which is 48 over 3 minus 2/3, which gives me 46 over 3. And that means that h is going to be root 46 over 3, or equivalently root 2 root 23 over root 3. Now I write it like that because in the answers, if you look at them, you see two of them have got root 23 in. Okay, but if you don't do that, we'll just, we'll realize that later on. But we're actually nearly there. So the volume is equal to a third times the area, which, let me just remind you, back up here was 8 root 6, times the height, root 2 root 23 over root 3. So Root 3 is going to cancel with, this is actually root 2, root 3, so I'm going to be left with 2 here. Root 2 times root 2 is 2. 2 times 8 is 16, so I'm going to get 16 root 23 over 3. And there we have it. A is our answer. So yeah, I mean, there's a lot of steps there, but I hope that makes sense. Um, I think this was quite a nice approach. Maybe not obvious, but sometimes when you're just doing these questions, you just gotta try some things out, and there's actually lots of different ways of getting the answer here. Now, I have seen an alternative method for solving this question when once you've got to this sort of stage, and instead of splitting it into this, well, you still use this green triangle, but you don't label this as X. You kind of forget about that. And actually, you draw a line going from here to the midpoint of RS. And think about this black triangle. Now, if we were to also connect it to R, then we would get an isosceles triangle because here to R is the same as here to S. I'm gonna get rid of that, but what it means is that this line is going down the middle of the isosceles triangle and we get a right angle. So I've got here, this is 2. And I'll explain exactly why we're doing this in a minute. I just want to focus on calculating some things. I've also got, remember, this length is root 96. So I can now work out, let's call this A and this M. I can work out the length AM. AM is going to be root 96 squared, so 96. And I'm going to minus this squared, so 4. Square root it. We're going to get root 92. So AM is root 92. And now I can think about working out this angle. I'm going to call it X. And I'm not actually going to work out the angle. I'm going to work out sine of the angle. So sine X is equal to the opposite, um, which is root 92, divided by the hypotenuse, which is root 96. And we can think about how this cancels down, actually. I think it's worth doing at this point. So it's going to be root 92 over 96. So I can, 4 goes into both, actually. 23 over 24, I think. Now, why is that useful? And this is what you have to realize. Like, so this method is just complicated in a different way. You can spot actually that if you return to our green triangle, let me keep it green, then that angle X is also an angle within the green triangle. Now within my green triangle, sine X is actually equal to the opposite, which is H. Okay, that was the whole point of this. I didn't want to say this right at the start, but maybe I should have done. So maybe I'll just recap. I've drawn a triangle going from A to M, and then from M to S, and then S back. I know that A to S is root 96. We calculated that earlier. And I know S to M is 2. I know this is a right angle because I've justified it, because if I joined A to R, I would get an isosceles triangle. So this must be down the middle. So I can use Pythagoras and I can work out the length AM. And then I can work out this angle, or sine of the angle, I should say, because sine of the angle, I can then use sine of the angle within the green triangle. And sine of the angle within the green triangle is going to be H over, so the opposite over the hypotenuse, H over 4. And that is equal to root 23 over root 24. So H is going to be root 23 over, let me think about this. So 4 actually goes into this number. It's going to be 4. It's going to be 2 root 6 times 4, because I've multiplied through. So I'm going to get 2 root 23 over 6, which is 2 root 23, which is actually the same thing as this. 2 root 23 over 6. If I was to times top and bottom, oh, sorry, was it root 6? If I times top and bottom by root 2, then I'll get 2 root 23 over root 6. I think I might have just made a, oh, sorry, I should have kept it as root 6. So yeah, it's exactly the same thing. Um, it's a nice method and it avoids, these equations that I had, but you have to spot that if you connect that midpoint that you can then use the same angle. Okay, I'm done with this question. Amazing question. Well done for sticking to the end of this video. Thanks.